Hello everyone, in this video let's discuss how to solve the AVL tree insertion problem. So it is a very easy problem. Let's understand the concept. So first, like the binary tree, so what will happen in binary tree? If you consider this as a parent node, it can have maximum of 2 child nodes. So now if you see the possible number of balance factor. So how to find this balance factor means how many number of child are there in left side minus right side. Here for this node there is no child in left side also, right side also. That is 0 minus 0 will be 0 itself. Here for this also there is no child for this node also there is no child. So you can conclude 0 minus 0 will be 0. Here for this node left side one child is there, right side another child is there. So 1 minus 1. 1 minus 1 will be 0. So the balance factor range will be from minus 1, 0 and 1. So if you get the balance factor as minus 1, 0 or 1, you can proceed with the problem. Otherwise you must do the minute changes. So what I will tell in the problem. So now let's start doing the problem. In the first step I want to insert 14. So I will directly insert 14. Now I only inserted 14. This 14 is not having any child. So you can conclude that no left child, no right child, 0. So at the first step we inserted 14 and its balance factor is 0. So I can proceed with next one. So now let's move to the second step. In second step I want to insert 17. So 14 will be as it is and 17 is greater than 14. So if the value is greater than the node, we will be writing towards the right side of that node. So 17 will be written right side. Now we must check the balance factor again for each and every node. So for the 17 is not having any child. So left side minus right side means 0 minus 0 will be 0 itself. Next for 14, left child is not there. So 0 minus right child is there. So 0 minus 1 will be minus 1. So I said the balance factor range is from minus 1, 0 or 1. So here we got minus 1. So we can proceed with the problem. Now at the third step I want to insert 11. So 14 will be as it is and 17 will also be as it is. Now if you compare 11 is less than 14. First you must compare with the root node, then only you must proceed with going as deep as possible. So if you compare with the root node, 11 is less than 14. So I will write left side towards the root node. So now again let's find the balance factor. For 17, if you see no child are there. So left side minus the right side, that is 0. Here for 11 also no children are there. So left side minus right side will be 0. Here for 14, one left node is there, one right node. That is 1 minus 1 will be equal to 0. So 0 is allowed in the balance factor range. So we can proceed with the fourth step. In fourth step I want to insert 7. So 14 will be as it is. 11 will be as it is. Next 17 will be as it is. Now I want to compare 7 first with the root node. So if you compare with the root node, it is less than 14. So left side. Again 7 is less than 11. So I will write left side towards the 11. Now let's find the balance factor again. So this for 7 it is not having any child, balance factor is 0. For 17 also no children are there, so balance factor is 0. For 11 if you see one left child minus there is no right child for 11. So 1 minus 0 will be 1 itself. Next for 14, 2 child are there in left side. So 2 minus at the right side we are having 1 child. So 2 minus 1 will be 1. So all the balance factor are allowed in the balance factor range. So we will proceed. With the fifth step. So in fifth step I want to insert 53. 14 will remain as it is. 11 will also remain as it is. 17 will also remain as it is. And 7 will also remain as it is. Now I want to insert 15. First I will compare with 14. So 53 is greater than 14, so right side. 53 is greater than 17, so right side. So I must write here. So sorry, this is not 15, this is 53. Now find the balance factor. This 53 is not having any child, so balance factor is 0. 7 is also not having any child, so balance factor is 0. So for 11, for 11, one left child is there, no right child. So 1 minus 0 will be 1. Next, for 17, no left child. So 0 minus 1 right child. 0 minus 1 will be 1. So this is also allowed in the balance factor range. Next, for 14, 2 left child, 2 right child. 2 minus 2 will be equal to 0. So this is also allowed. So now let's move to the 6th step, in which we will be inserting 4. So 14 will remain as it is. 11, 7, 17, 53. Now if you compare 4 is less than 14, it is less than 11, it is less than 7. So I must write 4 here. Now let's find the balance factor of each and every node. So 4 is not having any child, so balance factor 0. 53 not having any child, so balance factor 0. 7 is having one left child minus no right child, so 1 minus 0 will be 1. Next, for 11, if you see, 11 is having one left child minus there is no, so 11 is having two left child, 1 and 2, so 2 left child minus there is no right child for 11, so 2 minus 0 will be 2. Whether it is in the balance factor range? No, 2 is not in the balance factor range. So now we should make some minor changes. So what is the change means? 14 will remain as it is, and this is happening in the left side, that is in the left subtree. So the right subtree will remain as it is, 17 will remain as it is, 53 will remain as it is. So now if you see where the problem occurred at 11. Why it occurred? Because of 4 and 7. So we will be taking 4, 7 and 11 in the increasing order. So we must take them in the increasing order, and we will be selecting the middle element. So which is the middle element? 7. So what I will be doing is, after 14 I will write 7 here, and 11 will be the right child and 4 will be the left child. Now if you see the balance factor, it will be perfect. So for 53 no child, so balance factor 0. For 11 also 0. For 4 also 0, because no children. For 7 if you see, one left child and one right child, 1 minus 1 will be 0. For 17 no left child, so 0 minus 1 right child, 0 minus 1 will be minus 1. Next, for 14, 1 2, so 2 left child, 1 2, 2 right child, so 2 minus 2 will be 0. So in the 6th step we added 2 trees. Here first one was not having the perfect, that is it was having the balance factor out of the range. So what we did, we just updated the balance. So we just updated the AVL tree so that the balance factor was in our range, that is minus 1, 0 or 1. So now we can proceed with the next step, that is this is the 7th step. So in the 7th step we need to insert 13. So 14 will remain as it is, 7 will remain as it is, 4 will also be same, 11 will also be same, 17 and 53. Now if you want to insert 13, compare from the root node. So 13 is less than 14, so left side, but it is greater than 7, so right side, and it is greater than 11, so right side. So 13 will be written here. So now let's check the balance factor. 4 is not having any child, so 0 balance factor. 13 is also not having any child, so balance factor 0. 53 not having any child, so balance factor 0. Now for 11, no left child is there but right child. So 0 minus 1 will be minus 1. So which is allowed as the balance factor range. Next, for 7 if you see, one left child and two right child. So 1 minus 2 will be minus 1, which is allowed. For 17, no left child but one right child. So minus 1. Next, here for 14, you must take the longest one. 1, 2, 3. So 3 child, that is 3 left child minus 2 right child. So 3 minus 2 will be 1. So which is allowed. So now you can move to the further step, that is the last one. We will be inserting the 2. So how you will insert 2 means, so 14 will remain as it is, 7 will be same, 4 will be same, 11 will be same, 13 will be same, 17, and then it will be 53. Now I will compare 2 with the root node. So it is less than 14, so left side. It is less than 7, so left side. It is less than 4, so it is left side. So now let's check the balance factor. So all the nodes which are not having child will be getting the balance factor as 0. Next, for 4, if you see, 1 left child minus no right child. 1 minus 0 will be 1 itself. So it is allowed as the balance factor range. For 11, so no left child but only right child. So 0 minus 1 will be minus 1, which is allowed. Now for 7, 2 left child, 2 right child. So 2 minus 2 will be 0. For 17, no left child, only right child. So 0 minus 1 will be minus 1. Now for 14, you must take the longest one. 1, 2, 3. So 3 left child, 1, 2. 2 right child. So 3 minus 2 will be 1. So this is the final AVL tree because it has satisfied the balance factor range also. So this is the final AVL tree after inserting the given values. So hope you understood the topic of how to construct the AVL tree and insert the values. If you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, please subscribe and support us. Thank you.